In a number of thermodynamic problems, it is necessary to transform formulae from one set of variables to another. Two rules are applied for this task, namely the change of variable rule and the chain rule, also called the triple product rule. Let us see how they work. Let us take the differential of the internal energy as an example to illustrate how the change of variable rule works. Suppose, for example, that it is required to calculate the partial differential of the internal energy at constant pressure from experimental data. Now, the internal energy is more readily obtained from experiments in terms of temperature and volume rather than in terms of temperature and pressure. For example, the differential of the internal energy over the volume at constant temperature might be obtained from the thermodynamic equation of state, and the differential of internal energy over temperature at constant volume is a measurable heat capacity. Under the assumption of no change in composition, the internal energy is here function of temperature and volume. At constant pressure, we can divide this expression by the differential of temperature and obtain a new expression which relates the partial derivative of the internal energy over the temperature at constant pressure with other partial derivatives of the internal energy and of the volume. The first term is Cv, the heat capacity at constant volume. In the second term, the partial derivative of the internal energy over the volume at constant temperature and number of moles can be calculated from the thermodynamic equation of state. For example, if the van der Waals equation of state is used, this term must be A over d squared, where A is one of the two parameters of the van der Waals equation of state. The last partial derivative is also calculated from an equation of state, after making the volume explicit. This is the generic expression for the change of partial derivatives by using the general state function x. This expression is instrumental for obtaining a relation between heat capacity at constant pressure and heat capacity at constant volume. The last rule we introduce is the chain rule, which expresses a correlation among three different partial derivatives around the same thermodynamic function. We start by taking again the internal energy as an example and write the internal energy differential under the condition of no change of composition. We restrict to the case in which the internal energy is constant, but this is not an issue because all the results we obtain will be parametric function of the internal energy. Internal energy is here a function of temperature and volume. We divide the expression by dV and finally we divide again the resulting expression by the partial derivative of the internal energy over the temperature at constant volume, which is the first term of the last expression obtained. We end up with the application of the chain rule to the internal energy, when internal energy is a function of temperature and volume. From this last expression, we see that all quantities appear first in the numerator of the derivative, then in the denominator, and finally external to the partial derivative. This happens for u, for v, and for t. The general chain rule for a generic state function x, function of a and b, is built as follows. We prepare the ratios first, then we plug x in the numerator, denominator, and the external, and continue to do the same for a and for b. To help you with your memory, remember this order: upstairs, downstairs, outside. Try to do the same for v as a function of pressure and temperature.